We finally reached the last topic for this semester. Since we've introduced multivariable functions, we've covered derivatives, we've looked at optimization. So the only topic that we haven't covered yet is integration. So in this last module, what we want to talk about is how we integrate multivariable functions. First thing to keep in mind when we talk about these partial antiderivatives is that all previous rules and theorems still apply. So that means integration by substitution, integration by parts. Um, we very likely won't see problems as complicated as those integration by parts problems with multiple variables, but the same ideas apply here. All of those still apply when we're dealing with these multivariable functions. So the key change, since we're saying all these previous rules apply, is paying attention to which variable we're integrating with respect to. So since we have multiple independent variables, we're going to have to make sure that we're careful with identifying whether we're integrating with respect to one variable or the other. So for some given function, we could integrate f of xy dx, or we could integrate f of xy dy. So the dx portion is indicating that we integrate with respect to x. And the dy here is indicating that we would integrate with respect to y. So particularly in a business calc class, the dx that we always tag on at the end of these different integral problems has a tendency to come across as a little meaningless or kind of passed over, not seen as an essential step. But now that we're dealing with multivariable functions, this is going to be a very critical piece of every integral problem to make sure we're clearly identifying which variable we're integrating with respect to. So we always need to make sure we're paying attention to whether our problem ends with dx or dy, or if we had different variables in our function, ds, dt. So we're integrating with respect to that variable, and whatever the other variable is gets treated as a constant. So a very similar idea to when we looked at partial derivatives. One variable we would take the derivative with respect to, the other was treated as a constant. Here the same idea, we integrate with respect to x or y, and that other variable is just treated as a constant.